To start with, let us first understand what is software testing. And even before we understand what is software testing, let's first understand what is a software. A software, in simple words, is nothing but a set of instructions which are assembled together so that a particular action or an operation can be performed. Let's say you want to purchase a t-shirt at a mall and you want to pay for the t-shirt at the mall, you will be using your debit or the credit card. Now, in order that the store person makes the payment and records your payment for the transaction, they would be using your debit card, swiping it, noting the details, contacting the bank, taking the payment from the bank, and then give you the delivery of the t-shirt. So it sounds as simple as that, but there are a number of transactions that are happening in the background wherein you are handing over the debit card to the store owner. The store owner is swiping the debit card. It is contacting the bank's gateway. The bank is checking whether the card is correct. The bank is checking whether you have the correct balance. The bank is checking whether the store owner can be provided this payment. Then the payment is processed, which basically says successful or failure. And then the payment is made to the store owner, and then only he hands over the delivery of the t-shirt to you. So you see there are a number of transactions, or let's say called as activities, which are happening while you're trying to buy a simple t-shirt. So software is involved in multiple things over here, right from swiping the debit card or the credit card to reading its details, contacting the bank, getting the card information, getting the account information, getting the status back from the bank, supplying it to the store owner's bank, and it could be different banks also over here, and then having the transaction successful. In this similar manner, there are multiple softwares that we use on a daily basis. On a daily ongoing basis, there could be buying of milk, buying of cheese, buying of fruits and vegetables, or maybe let's say if you're paying for your car ride, or if you are getting your salary, or if you're paying for any expenses, anywhere. It is either money coming in, money going out, or it could be as simple as surfing the internet, wherein let's say you are using a Google search engine to search something, you are using Microsoft PowerPoint as a software to create slides, you are using Microsoft Word to create a document, and so on and so forth. So these kind of softwares are always available, which are called as let's say utilities, or which are called as banking applications, or which could be let's say your booking applications or hotel applications and e-commerce applications and so on. So all these applications in the background basically have huge and huge lines of code written, which could be in thousands, let's say 10,000 lines of code and 20,000 lines of code written in different programming languages such as C, C++, Java, .NET, and so on, which would enable you to use the software for a particular business transaction, or for learning, or for browsing, or for surfing, or for watching an audio, or watching a video, listening to audio, sharing files, sharing photos, and so on. So that is in short what is meant by a software basically. Now coming to testing. Testing is basically a process which will help you to identify how good is the software that you are using. Now, if you look at testing other than software testing, it could be there in your day-to-day life also. Let's say if you're even buying a t-shirt, again coming back to our earlier example wherein you were buying a t-shirt at a particular mall, you will be testing the t-shirt for your size. You will be going to the trial room, you will be measuring the size, you will be verifying whether you fit into the t-shirt, you will be checking the color, you will be checking the buttons, the collar, and so on and so forth, the fabric, stitching, everything. So you see, testing is always present, it always exists in our day-to-day life. In terms of software testing, we are talking particularly about testing of a software, like the number of softwares that we just mentioned a few minutes ago. So in there, what we are doing is we are utilizing and we are using the software in different permutations, combinations. There are different test strategies or different activities that we are performing with the software, And at the end of the testing, we are determining whether this particular software can be used in the live environment, or does it have to be tested more? Does it have to be fixed? Are there any issues which the end user might encounter? Software testing basically involves verification and validation, which is in short called as the V and V process. What it basically does is it verifies whether the software is working fine, and it also validates whether the software should be working in a particular manner. Like we have mentioned over here, software testing is performed to verify that the completed software package functions according to the expectations defined by the requirements/specifications. We will see in detail once we understand software development life cycle on what do you mean by the requirements and specifications over here. But in short, if I have to mention, what it means is that let's say a customer has defined a particular requirement. Let's say you have defined the store owner that you want to buy a blue t-shirt. Then when the store owner is providing you a blue t-shirt, it definitely has to be blue, correct? Otherwise, you won't buy it because it is not blue. So your requirement is met only when the store owner satisfies it 100% and nothing more and nothing less than the requirement. And let's say if you have mentioned a collared t-shirt, then obviously the t-shirt needs to have a collar. And if you have mentioned a round neck t-shirt, obviously the t-shirt needs to have a round neck. So these are the requirements what you are providing to the store owner. The owner is basically verifying its inventory and validating that your customer requirements are met, and then he is delivering the t-shirt to you. Like the last point what is mentioned, the overall objective of software testing is not to find every software bug that exists, but to uncover situations that could negatively impact the customer usability and or maintainability. Like in your t-shirt example, let's say if it is of a different color or a different size or of a different fit, you will definitely not buy because it does not match your requirement. So like I mentioned before, the customer requirement needs to be met, and only then the delivery of that particular item can happen. That is why if you see, software testing is so necessary that it will ensure that the customer requirement is 100% met, and then only can the testing team specify that the product can be delivered to the customer. We need to understand why do we need software testing. Like we saw in the t-shirt example also, that software testing is very essential if you are paying, and let's say if the store owner is using a software which does not verify the card details correctly, and let's say if there is no balance in the card and the payment still goes through, and he delivers the t-shirt to the customer, and later on he figures out that there is no payment made to his account, basically that's a loss to him. And that's a loss because of the software which was being used was faulty. By faulty, what I mean is it was failing to detect the card details. Let's say the software did not verify whether the customer had appropriate balance in their account or no. Let's say the t-shirt was priced as 500 rupees, so the customer should have at least 500 rupees in their account open, so that when the card is being swiped, 500 rupees can be paid to the store owner. But let's say if the money in the account was less than 500, and still then if the transaction is going through, then it's a wrong validation from the software side, and which is very, very serious. Imagine if the store owner uses the software and provides t-shirt to any of the customers coming to his shop. He might have all the t-shirts sold but might not get payment for either of them. That is the reason software testing is very, very important. Like we have mentioned the first point over here, software testing is important as it may cause mission failure, impact on operational performance, and reliability if not done properly. In the second point, what we are mentioning is effective software testing delivers quality software products, satisfying users' requirements, needs, and expectations. So basically, the customer's requirement of buying a particular blue t-shirt and paying it correctly for it was met by the store owner. The store owner is also satisfied because he has delivered the product, the t-shirt, he has got the payment for it in his account, and the expectations are matched from either side. And Since the software testing had happened correctly, the store owner got paid correctly. Hence, the transaction was successful and then the product can be delivered to the customer. Let's determine on who is a software tester. If we have to define it, like mentioned in the slide, we can say that software tester is a person who performs testing and finds bugs if they exist in the application under test. In plain language, if we have to say, the software tester is a person who is using the software as an end user. So let's say if the software was defined for the store owner to take the debit card from the customer, swipe it, ensure the payment is done to the store's account, then the software tester is a person who will put himself or herself in the shoes of the store owner and then have the transaction performed to see whether the transaction is going successful or no. Now, in addition to that, what software tester is going to do is to verify the negative scenarios also. Now, why I say positive and negative scenarios? Positive scenario is wherein the customer has given the debit card and the store owner is using the debit card in a really positive manner, in a happy to part scenario, entering all the details, verifying if the payment is done, and handing over the product. But let's say if the store owner wants to use the debit card in a separate manner, let's say there are some negative test cases that need to be tested. The store owner will not be doing it, but the software still needs to be robust enough to ensure that the software works. That is the reason software testing comes into existence. It will ensure that not only the positive test case is working, but it will also ensure that the negative test case is not working. So let's say in the earlier example wherein we saw the store owner was swiping the debit card, and if there is no balance, then that is a particular negative scenario what is happening. And in that negative scenario, the software should have alerted that there is no balance and the debit card cannot be used and the t-shirt should not be delivered to the customer. So these kind of scenarios are covered by software testers wherein they will use the debit card for a positive transaction wherein the transaction goes through successfully, and they will also try negative scenarios wherein the debit card should not have worked and the software should have alerted. So basically, they not only have to try positive scenarios, but software testers have to be so analytically strong that they need to try the negative scenarios also. And believe me, the negative scenarios are the ones which have no limits. Positive scenarios would definitely have limits in terms of the actual functionality, what is expected, but software testers really need to be very, very smart, very detail oriented, and analytically strong to identify these kind of negative scenarios and put the application under test for these kind of scenarios also, in addition to the positive scenarios, and then determine the behavior of the application. Now let's ask ourselves, is it possible to test everything? Now, what do you mean by everything? Like we discussed, we are going to test the positive scenarios and the negative scenarios for the debit card transaction. So if you look at our points on the slide, it says exhaustive testing is not possible. Possible inputs and outputs are very large, like what I just mentioned about the negative scenarios on a debit card. Software specification is very subjective. Too much independent path, and the solution of the problem is follow the principles of testing. Now, when we say is it possible to test everything, we need to determine what is the scope of testing. Like I mentioned earlier, there could be hundreds and hundreds of scenarios of negative testing. What need to be tested, not only for a debit card transaction, but let's say for an entire application as a whole. But we need to determine on what exact scenarios do we need to execute and what exact scenarios that we do not need to execute. Let's say there could be certain assumptions that could be made while you are testing. And if you have those assumptions, then you could ignore those assumptions and then focus only and only on the required positive and negative scenarios. Now, how do you determine the scope of that testing? We will see that later when we come to the test planning phase, wherein we are determining the scope and the test strategy. But for now, let's understand that if you have to test a software application, you have to test it 100%. 100% I mean 100% of positive test cases and 100% of negative test cases, which will help the day-to-day running, the day-to-day execution of the application under test. In under no circumstances it should there should be a condition wherein the software cannot be used. Either the workaround should be available so that the software can still be used, or either such kind of defects need to be fixed. But yes, we need to agree that there could be very rare scenarios which might occur, let's say in one in hundreds or one in thousands, which could still be ignored. And why I would say those could be ignored is because their probability of occurrence is very less. That is the reason testing is always based out of the software specification, like what is mentioned in the slide also, that software specification is very subjective. These software specifications always need to be referred whenever you're defining the scope of testing. And we will see these points in detail once we come to the test planning phase. Now, the solution of the problem is how do you determine of how many positive test cases to be executed and how many negative testing to be done. So for doing that, the simple answer is to follow the principles of testing. Principles of testing. Testing should be done at optimum level, which is neither under testing nor over testing. Now this is a very good line which basically gives us the boundary of what testing needs to be executed. Now if you see, the stress is given over here on the word optimum. Optimum lies somewhere between minimum and maximum. So it is not very minimal testing that you are doing, and it is not even the maximum testing, let's say, which has no end. Like you must have heard, testing is a never-ending process. There is always one more bug, like what is said in the software testing industry. There is always one more defect which always exists and which could still be there, but the probability of such a defect could be 1 in hundreds, 1 in thousands, or a very rare scenario which might exist, let's say, once in a year, once in a 6 months, and so on. So what our goal should be that the software should be ready to be used on an ongoing daily basis. Now let's say if you want to use Microsoft Word to create documents daily, then you need to have all the functionality available which is required to create the document on a daily basis. Let's say there is a functionality which breaks once in 6 months or once in a year or once in multiple years, or like I mentioned earlier, once in 100 or a once in 1000 activity, then that is absolutely fine. And you could still leave that defect, ignore that defect, and still use that product, because that particular defect which exists does not make the software unusable. It still does not let you negate the fact that the software is not used or not usable. So you can still use the software, you can still do your daily activities using the software. That is not a showstopper, and your daily activities or daily business transactions can still be performed. So definitely you should ignore these kind of defects. A very good point which is mentioned on the slide, which says too little testing is crime, too much testing is a sin. So what we are saying is too little testing is crime. What it means is that if you're testing very little, then you are not uncovering all the scenarios. Then you are not trying to test it robust enough. Then you have not done enough testing. And there could be defects, there could be issues with the software which could be open, which could be obvious, and which could be very naturally transparent to the end users. And these kind of issues you definitely don't want, because then it will prove that the software testing was not done appropriately. Like we mentioned the debit card issue also, wherein the bank was not verifying the balance of the customer and it was still getting through the transaction as successful. So the store owner did not get the money, but the customer still got the t-shirt without even paying a penny for it, which is absolutely bad for the store owner's business. So that could have been an issue as a result of too little testing that was being done. So why it is called as a crime? Because it will have failures. The software could fail, the business could fail, the operations could fail, and so on and so forth, and it could lead to huge, big financial losses. Now, coming back to the second point, which says too much testing is a sin. Now, what happens is, like I mentioned, I mean, if you're testing for months and years and so on, and if you have the software robust enough to handle let's say 99% of transactions, or let's say 99.99% of transactions, but let's say one of the rare scenarios does not work correctly, then there is no reason for the testing to continue, and there is no reason for the release of the software to be stopped. The software could still be released, the software could still be used, and if you still continue to do testing and stop the software from not being used, then that is basically a sin, because again there will be huge financial losses, there could be huge operational losses over there also, because there could be users who are waiting for the software to be completed so that they can be used. But if you are continuing to test and not letting them use, then obviously that is again a sin from our side. So like the word again I'm coming to, as mentioned on the slide, is optimum. So optimum is between this crime and the sin position, wherein it needs to be just right so that the software testing is concluded and the software is started to use in the actual environment. Let's move forward and let's look at some general testing principles of what we might have discussed earlier also. The first one shows testing shows presence of defect, which is absolutely correct. By testing the software, you will be able to clearly indicate what is the issue. You will be able to identify the problems which are very obvious, which should not have been visible to the end users, and which will obviously make the overall quality of the software good enough. And exhaustive testing is not possible, like what we mentioned. I mean, it is impossible to test the software for its entirety. Why I say entirety? Because I know there is always one more bug and there is always at least one defect in the software, but the only thing is whether it is identifiable or not identifiable. Now let's understand what we really mean over here by saying exhaustive testing is impossible. It doesn't mean that you do very less testing and leave the defects as an excuse over here. So that this is nowhere an excuse for a tester to say that okay, exhaustive testing is not possible and hence I will not be testing more and let the software be released. But on the other hand, the tester also needs to understand that they do not test for so many months and so many years that the software is not usable by the users and it is still lying with the testing team itself. So like we said, I mean, there is a thin line between when should the testing be started and when should the testing be stopped, and when shall we conclude the testing. So we need to be very careful to determine that particular phase wherein we can say that okay, exhaustive testing is done, full testing is done, and now the software can be released, but there could be issues which will not be visible to the end users and which the software can still live with. The other testing principle which is more important is early testing. Now, in terms of early testing, what we want to mention over here is that the testing should start as early as possible. It should be starting right from the analysis, conception, requirements phase of the application, then go on to the design and development phase, and then actually get into the testing phase. Now, these different phases we will understand when we see the software development life cycle, more popularly called as the SDLC. But for now, in short, if we need to understand early testing, what it is meant over here is that the testing should start as early as possible when the application is being developed. That way, what happens is when the application is under development, the testing team could identify the issues and they could fix it then and there itself. They, as in the developers, could fix it then and there itself so that the testing team later on can focus on the core functionality of the application and the other defects which are not identified in the early phase. But at least small, minor, low and medium issues which could be identified in the early phases should be fixed at that particular early stage itself instead of having them ported over to the future phases and then trying to fix it. And this definitely increases the cost of quality. We will again come to this particular point when we look at the test planning phase. The next one is defect clustering. Defect clustering basically means the piling up of defects on one above the other after one round of testing to other, which happens when you are trying to test too many things at once. Instead of that, like was mentioned in the earlier point, some level of testing should have been done in the earlier phase so that later on you don't have like hundreds and 200s of defects out of which at least 50-60 could have been closed in the earlier phase itself. Okay. The other thing is the pesticide paradox, what you mentioned and what we refer to as in the testing principles, wherein the testing should be spread across different phases. So that way the testing is focused across all the activities of the STLZ. Testing is context dependent, which basically means that it verifies or validates the exact business context of the application, and it is not vague, or it is not non-focused. It is obviously focused to verify and validate a particular activity or transaction or an action in the software. And the absence of error falsi. What it basically means is that if you have confidence that there are no errors, there are no obvious errors, then definitely the testing can be concluded and the software could be then utilized for the actual purpose of it. Next, we will see some more testing principles and we will understand how they can be implemented. Like the first one, which says testing shows presence of defects. Like what we discussed earlier also, if you do not have testing, obviously there could be bigger issues, there could be major flaws in the software if it is left untested. That is the reason we need testing to happen and developers fixing those defects. So testing shows presence of defects. Testing can show that defects are present but cannot prove there are no defects. Now we need to be very careful about this bullet point over here, which let's break it up into two parts. The first part, which says testing can show that defects are present. So what testing is basically doing is identifying the defects, reporting the defects and getting it fixed by the development team. How are they identifying it? Is by subjecting the application to positive and negative scenarios and building up a comprehensive list of defects and ensuring that the entire application is tested for each nook and corner from end to end from all the components aspect. Now, the second point within the same bullet says that testing cannot prove that there are no defects. Now, in any ways, there is no test strategy or there is no step available which will prove that there are no defects. But if I rephrase this statement and mention it by saying that testing can be concluded wherein there are no more obvious defects or there are no more defects that are identifiable, that is the particular stage when the testing can be concluded, which in other words means that there are no more defects which the testers can identify, or there are no more defects which would be obvious to the users of the software. And since these two conditions are being met, then what we can say is that there are no more defects which exist in the application which can be identified by a tester or an end user. Hence, it can be assumed that the software is safe and it can be handed over to the end users for their actual usage. Now looking at the second point, testing reduces probability of undiscovered defects remaining in the software, but even if no defects are found, it is not a proof of correctness. Now we need to be very careful about this bullet point on what it means. Testing reduces the probability of undiscovered defects, which is correct because if there are any defects which are undiscovered, testing team will be finding them, discovering them, detecting them, searching them, hunting them with the different words to define it, and they would be reporting them and getting it fixed through the development team. So that is the part wherein the probability is reduced. Why? Because if already all these types of testing have been done, then the probability of finding new defects is obviously very low. Now, in the second point, what we have also mentioned is that if no defects are found, it is not a proof of correctness. So, which in other words means that if the tester cannot identify more defects, or if the end users cannot identify more defects while they are using the application, it still does not mean that the software does not have any defect. The software could still have at least one or two defects which again might not be identifiable by the tester or might not have been experienced by the end user. So it is still not a proof of correctness, or it is still not the guarantee of 100% that there is no defect. But again, let me reiterate the earlier point that if the tester or the end user cannot find it or cannot experience it, then the software is considered to be bug free and they can definitely start using the software. The second principle again explained in detail over here, which is about the exhaustive testing being impossible. So testing everything, all combinations of input and preconditions is not feasible except for small cases. Now what happens is there are certain softwares, there are certain big softwares which could take years to be developed and months or years to be tested. But in those type of conditions, there is something called as a sampling testing that is done. So let's say if you want to identify or if you want to test the same record for about, let's say, 100 different of test data, what you might do is you might still test, let's say, 20, 30 or 40 of those test data, but you might not repeat the test data for the entire 100 entries. Why? Because testing that much of volume might take too much and too much of time, which might not be required or which might not be important. Rather than that, the testing team could focus on more important scenarios which could help them uncover more business critical defects rather than trying to verify the same test data for 100 different times. Instead of exhaustive testing, we use risk and priorities to focus testing efforts. So like I mentioned earlier, even if you don't want to test the 100 rows of test data being entered, what you could do is you could identify what is the most riskiest item in the application. And the very first thing what you do is test the application for that particular riskiest item in the first attempt, and you prioritize that as the most important thing, the most critical thing that needs to be tested. Then the testing effort could then be steered towards other activities which might not have the same priority or the same criticality, like of the first or the second one, which is the main core business of the application. So if your main core business of the application is working fine, and let's say if there are very low or minor issues in some other trivial functionalities, then those can definitely be ignored. Now again, it does not mean that exhaustive testing was not done. The exhaustive testing was done, but it was done more on the core business of the application and less on the trivial functionalities. Now, the next principle, like what we saw earlier, is the early testing. Testing activities should start as early as possible in the software system development life cycle and should be focused on defined objectives. Now, like we mentioned earlier, that there are different phases of software development life cycle, and testing should be started right from the beginning of the software development life cycle, right from the inception or the conception phase, wherein the actual software to be developed is being thought about. Right from that phase to the actual design development of the application, the testing should be involved and testing should be included in all those phases so that they could participate and contribute to the best quality of the application. And testing should be focused on defined objectives. Now, what do you mean by defined objectives over here is that your testing should be focused on a particular activity or on a particular phase or a stage of software development lifecycle. Now, let's say if you're trying to validate the requirements which have been written in the requirements phase of the software development life cycle, then your objective should be only and only to validate the requirements for which the application is being developed. Otherwise, what will happen is you will lose the focus and then you will start testing something else which might not even be a priority item. That is why starting testing in the early phase is required and focusing it on a particular objective is very much required. The next principle number 4, is defect clustering. A small number of modules contain most of the defects discovered during pre-release testing. So like we discussed earlier in defect clustering, wherein there are different modules and If you try to test all the modules at once, then definitely there would be defects that would be clustered and piled up upon each other, and then the development team has to go through all of those modules and their defects at once. Instead of that, if you stagger it and if you arrange the modules in terms of their priority, and if you initiate the testing of some of the modules before even the build comes for you to test, then definitely it makes sense and you could identify at least some percentage of defects during the pre-release testing itself. Now, the next point is principle 5 about pesticide paradox. If the same tests are repeated over and over again, eventually the same set of test cases will no longer find any new bugs. To overcome this pesticide paradox, the test cases need to be regularly reviewed and revised, and new and different tests need to be written to exercise different parts of software or system to potentially find more defects. Now, what it means is that if you are testing the same application for, let's say, 10 particular scenarios, and every time if the 10 scenarios are passing, it does not mean that the software still works. What you should be trying is, you should be trying 5-10 more scenarios which are in addition to the earlier 10 scenarios, and ensure that all of these scenarios are failing. So that way what happens is the variety of test scenarios and the variety of testing to test each of the module grows, and as it will obviously grow as the volume of the application under test also grows. Hence it is very much required for you to spread out your testing into different phases of SDLC and always be on a lookout for expanding your test coverage and definitely not reduce it. Testing is context dependent, so like we discussed earlier, testing is done differently in different contexts. Context basically is the objective or the requirement of the testing. For example, safety critical software is tested differently from e-commerce sites. So safety critical software, which basically, let's say, is being used for a biometric attendance system, or let's say if it is trying to do any safety transaction for building security or for, let's say, an office security and so on, that will be tested very differently from an e-commerce site. E-commerce sites, there are so many e-commerce sites, let's say Amazon, on which you are buying multiple products by using your debit card and credit card, internet banking and so on. So the test strategy or the test approach to test an e-commerce site is way beyond and separate from testing of a safety critical software. So these contexts need to be remembered when you are trying to test a software. So let's say when you are trying to test a banking software, then you need to remember the compliances and the regulations and the rules what need to be applied for testing of a banking software. So you need to ensure that all these compliances, regulations, rules and policies are taken into account while the banking software is being used. Otherwise, it could work from a functional side, but definitely the functionality, if validated against these rules and regulations, the functionality might have violated either of the policies, or it might have been causing a loss to the bank. So we need to be very careful when we are testing these kind of applications, and we need to focus on the background context of exactly what are we testing. The next principle is absence of errors fallacy. Finding and fixing defects does not help if the system built is unusable and does not fulfill users' needs and expectations. Like what we discussed earlier, the application under test should satisfy the customer's requirement 100%. It should not even be less than 100%. It should not even be more than 100%. So if the particular requirement has been stated and documented and circulated to the development team to develop in a particular manner, then it has to work in exact particular manner and no deviation from the customer requirement. Okay, let's see the next point, which is who should test. Now if you see the two sides of the slide, one side is the developer and the other side is the tester. From a developer, the bullet point reads understands the system but will test gently and is driven by deadlines. Whereas for the tester, The tester must learn the system which is under test, will attempt to break the software, and is driven by quality. Now, if you see, the aspects or the sides of the developer and tester are very different. Like what it is said, the developer has a make attitude, but the tester has a break attitude. So what happens is the developer is always trying to make the software work in whatever condition it is, maybe by error fixing, or maybe by matching to the requirements, or maybe by debugging, and so, or by providing workarounds. But the tester always has the tendency to identify issues which could occur while using the application, and basically they want to break the application such that it becomes unusable. So the developer is always focusing on what is usable, whereas the tester is always focusing on what is unusable. And also the developer is focused on the deadlines, wherein the tester is testing, but the developer wants to finish the testing as soon as possible so that they can release the application. And they have a certain deadline to be met. But for testing, it is always better that they keep the deadlines aside and they focus more on quality. Now, what do you mean by focusing on quality over here is that the tester will ensure that the application meets the required quality standards, it meets the requirements, it meets the specifications that were documented, it meets the customer's requirements 100% in an accurate manner, and the quality experience of using the application is 100% fine and acceptable. If all these criteria are met, then and only then can the testing be stopped. Otherwise, the testers obviously will not permit the application to be used in the live environment, and they would ensure that the quality is at least up to the standards what have been defined by the end user or by the customer or by themselves. Typically, it is the testers who determine what are the quality standards that should be implemented while the application is being developed. So when the application is about to go to the end user, the testers will ensure that the quality standards are met and the end user's requirements are also met, so that the end user does not complain anything while they are using the actual application. So let's see, what do you mean by quality assurance? Quality assurance is a planned and systematic set of activities necessary to provide adequate confidence that products and services will conform to specified requirements and meet user needs. Like what we just mentioned in the earlier point, the quality assurance will ensure that whatever has been specified in the requirement, the actual application meets the requirement specification 100% exact, accurate, complete, and then only would it certify that the application can be used. So over here, quality assurance is process oriented, quality assurance is defect prevention based, quality assurance appears throughout the life cycle of the software, and quality assurance is a management process. So in terms of process oriented, what I would mention is quality assurance basically has defined processes, and we will see this in much detail later, but for now, if we need to understand the quality assurance processes, we need to note that there are certain processes that would have been documented for the software development life cycle, and for each of the phases there would be certain processes that need to be followed. If these processes are not followed, then quality assurance obviously raises an issue over there, and they try to ensure that all the processes have been followed as per the set documentation or as per the set guidelines. Now, why is quality assurance defect prevention based? Because it focuses on preventing the defects to exist rather than trying to report defects and then fix it and then retest it and so on. So the requirement or the objective of the quality assurance function is to confirm that the software processes are being followed and the software is being developed in a particular pattern or in a particular manner as documented by the quality assurance function. And if all those are followed 100% and if all the processes are adhered to, then it certifies that there would be less defect, and it certifies that the quality assurance is 100%. Now again, why is quality assurance required throughout the life cycle? Because, like I mentioned earlier, there are different processes that need to be followed for different activities across the software development life cycle. And that's the reason quality assurance is a function which is available for throughout the SDLC, and it is not only during the testing phase. Why quality assurance is a management process? Now, management over here is meant by the senior management, because for somebody to implement the quality assurance process, you need to buy in the process. And what I mean by buying the process is this: you need to understand the process, you need to adhere to the process, you need to trust the process, and you need to follow the process as a 100% disciplinary action. Otherwise, if the process is documented and not followed, then it is again a loss to the quality assurance function and all the impacted functions who are not utilizing the process. Like, the processes are always built to ease the action of different team members, and it is definitely not an overhead for all the project stakeholders or team members. Now, why this is the management process? Because the management process or the management team ensures that these quality processes are embedded throughout the software development life cycle, and they oversee the entire process so that the process is publicized, the process is circulated amongst all the team members, and it is in conformance with all the project stakeholders that they will be following this particular processes, and the required outputs will be then available. The next item what we will see is quality control, which is definitely different and very different from the quality assurance part that we just discussed. Quality control is the process by which product quality is compared with the applicable standards and the action taken when non-conformance is detected. This particular process or this particular activity of quality control is product oriented. Now, what quality control does is it verifies, it validates the application under test against the set processes that have been built for the entire SDLC. Any deviation from the software process or any deviation which is found in the set standards, these type of deviations are then marked, indicated, documented, and then fixed. Now, why is quality control product oriented? Because it focuses on the software application which is under test, and it ensures that the software application under test has been built by following the documented standards which would have been applicable. And like I mentioned earlier, if there is any deviation or if there is any issue or if there is any discrepancy in the product that has been built and in the process that was set, then these types of non-compliances or non-conformances are then documented. And again, what we need to ensure or what we need to remember is that quality control is defect detection based. So like quality assurance function was defect prevention based because it was trying to prevent the defects in all the phases of the software development life cycle. In quality control, defects reporting, defects detecting, and the investigation is given more importance because all the non-conformances and non-compliances are logged as defects and then tracked throughout the software testing life cycle. So let's quickly see what is the difference between QA versus QC. Now, what we saw is that quality control makes sure the results of what we have done are what we expected. Basically, it checks that what was required as per the requirements and specifications is being built and has been built according to what was required. QC focuses on testing for quality and hence detecting defects. So like we mentioned earlier, QC or quality control is a function which is going to detect the defects. It is going to discover and it is going to find out the defects, report them, and it will focus on the quality that can be improvised by fixing these defects. So it is basically concerned more about the application that is under test and less on the processes that are being followed. Quality control deals with the product, which is the application or the software under testing, and quality control is for testing part in the software development life cycle. So this is basically for the testing phase which comes under the software development life cycle, and that testing phase is again encompassed by the software testing life cycle, which we will be seeing in detail later. Quality control is more of a corrective process. Now, why it is more corrective and not preventive is because the quality control function is reporting the defects after the defects have been identified and after they have been detected in the actual application which is being tested. Now, why quality assurance is a preventive process? Because quality assurance is identifying issues much before the application is under testing process. So it is existing, the quality assurance function is existing right from the beginning of the application trying to be built, and it is trying to prevent the defects so that there are less and less number of defects which exist in the actual testing phase. Quality assurance makes sure that we are doing the right things the right way. Quality assurance focuses on building in quality and hence preventing defects rather than being corrective, as we saw in QC. Quality assurance deals with the processes that are being followed for different phases of SDLC. Quality assurance again is for the entire life cycle and not only for the testing phase in the software development life cycle. Any questions, comments, please feel free to ask and we'll be happy to answer. In terms of quiz, I wanted some questions to be asked so that you can understand these questions and refer to your slides and refer to the discussions what we had. Like primarily you need to understand who owns quality assurance function, who owns the quality control function, what are the major differences in between quality assurance and quality control. Can a developer test their own code? We need to remind ourselves about the slide wherein we saw the difference between a developer and a tester and what are their different activities and what are their attitudes in terms of making and breaking the software. Why do you need a tester? Again, remind us of the banking transaction that was happening wherein the store owner was swiping the debit card and the payment was going through even if the customer did not have any balance. So imagine if there was no tester, if there was no software testing, then these type of software glitches, these type of issues will definitely occur. And what are the best qualities of tester? Now in the entire chapter what we discussed are the different qualities or the different characteristics of software testing team or the tester as an individual need to have. Like we mentioned about the analytical skills, we mentioned about the smartness, we mentioned about the detail oriented, how they should be, the attention to detail, what they need to have, the eye for detail that they need to have, the attitude that they need to have so that they can verify and validate that the software is being built according to the customer specifications, how they are going to channelize their energies towards detecting a defect, towards preventing a defect in both the quality assurance function and the quality control function, and so on and so forth. Thank you very much.